Hello, welcome back to my tutorial. Um, Sorry it took me a while to get this next tutorial. My wife just had a baby. Anyway, the last tutorial I created was all about how to set up static routing. And what I want to share with you guys this time is how to do dynamic routing. Um, what I'm going to be talking about today are internal dynamic routing protocols such as RIP version 2. We got EIGRP and OSPF. So, but we're not going to be talking about BGP. BGP is actually outside of the CCENT or CCNA topics. Okay. To start up with dynamic routing protocols, I pre-created a topology right here. It's a simple 3 router topologies with switches connected to those routers, and I've also pre-populated information that we'll be using to set up these routers and to show you how dynamic routing protocol works. So if you notice, here are the network addresses. Alright, and if you notice as well, I kept /24 in all of the network addresses. Now I wanted to keep /24 in all of the network addresses to show you how dynamic routing protocol works, and especially how does administrative distance play a key role when it comes to using dynamic routing protocol. Just to let you know, if you're thinking of taking CCENT and CCNA, admin is, you really have to be familiar with the administrative distances. Okay, like the important ones that I can think of that were in the exams were connected. This is an administrative distance of 0. Static connection 1. EIGRP of 90. OSPF 110. RIP, it could be version 1 or version 2, 120. It's the same administrative distance. Okay, I'm gonna explain to you and show you later why administrative distance is so important to understand. All right. Now, why is dynamic routing protocol important? To know the path to other network addresses. Like for example, if we don't set up dynamic routing protocol to these 3 routers, router 0 will only know the path going to the serial interface 2/0 of router 2, and the path going to the serial interface 2/0 of router 1. Besides that, router 0 will not know how to get to network address 150.10.6.0, okay, because there's no dynamic routing protocol. Only the directly connected ones are the ones that router 0 know how to get to that next connection. Alright, so we'll start to set this up. Oh, by the way, some information that I've added here. These dots right here, .3, .3, .1, this is just to help us keep track of what is the last octet that we use in this network for the IP address of this interface. For example, router 0 serial interface 2/0, the IP address that we'll be setting on that one is 150.10.1.3, and for router 2, that's gonna be 150.10.1.2. Alright, and these are the interfaces. Okay, so let's try and set things up. Yeah, let's start with router 0. Now when you see this dialog box, just press no for that one, and then hit enter. Now, and if you notice as well, the host name here is just router. If we're gonna check router 2, it's gonna be the same router. So just to not confuse ourselves, what we're gonna do is that we're gonna set up and change the host name as well. Like for example, that router right there, we're gonna have it match with the router name right here. Okay, we can do that by okay, hit enable first and then go to global configuration command. You can do that by typing in configure terminal. Now we're inside the global configuration command, and to change the host name, you just have to type in host name and the router and the name that you wanted to appear. Like we wanted it to match router 0 right here, so we're typing router 0, and there it is. Now let's go ahead and set up the serial interface 2/0, serial interface 3/0, and fast Ethernet 0/0 of router 0. Okay. Now, since we're using /24, all of the subnet mask that we'll be using here is going to be 255.255.255.0. Okay, and always remember, when you set up IP address to the interfaces, make sure to put in the no shutdown command to power up the interface. Okay, now let's do 0.3/0. 150.10.3.3 shut down. And now the fast Ethernet 0/0. 5.1, and again the no shutdown command. Alright, so we're pretty much done with router 0. Let's do router 1 and router 2. So this is router 1. Okay, router 1, 2/0. That'd be 150.10.3.1. Oops. Alright, now let's go to router 2. Oops. 2. Okay, now that we've set up all of the routers with their IP addresses, with all of the active interfaces, let's go ahead and check the routing table. Okay, now remember, we still haven't set up a dynamic routing protocol on these routers, okay, which is assigned IP addresses to the interfaces. So if we're gonna check the routing table, all we can see are the directly connected ones. Okay, like for example, router 0. So it says it is directly connected to 150.10.1.0 network, and it says to serial 2 right there using the serial 2 connection. Okay, and even the fast Ethernet right there. All right. Oh, and yeah, serial 3 right there, going to 150.10.3.0 network. Okay, now we're gonna set up dynamic routing protocol. If you notice, router 0 doesn't know about 150.10.4 network.0, and it doesn't know the 150.10.6.0/24 network, because we haven't set up a dynamic routing protocol. Okay, just put it right there. Okay, let's start by setting up routing 0, and let's start with a RIP routing protocol. Okay, again, go to global configuration command, and to tell the router to use the dynamic routing protocol RIP, you just have to issue the command router RIP. That means like, hey, I want you to use the RIP routing protocol. And all you have to do is type in the command network 150.10.0. Now, we just have to type in network 150.10.0.0 because that covers all of the network addresses that we're using right here. Okay? And then just hit enter, and you're pretty much done with that. Let's do it with router 1, router RIP, and then network 150.10.0. Let's just put end on that one so we can network and alright. Now if we're gonna do check the routing table again by doing show IP route, now you notice it's not just the directly connected anymore, but we have R, and R means RIP right here. That means we're using the RIP routing protocol. Okay. Now let's double check it with the other routers as well. Okay. Alright, so now let's take for example router 0 again. Router 0, earlier when we haven't set up the dynamic routing protocol, it doesn't know network 150.10.4.0/24 and as well as 150.10.6.0/24. But if we're going to look at the routing table of router 0, now it has an entry going to 150.10.4.0. Okay, because we've set it up. Now, what if we're gonna set up and try and set up another dynamic routing protocol? Now that is where this administrative distance will come in. Like for example, as I mentioned, it's very important for you guys to know about this. We've set up RIP, and RIP has a 120 administrative distance. Now the lower the number of the administrative distance, that means the more trustworthy the protocol is. So if I were router 0 and for example in all of these routers, you know, RIP was configured and OSPF was configured at the same time, router would be like, okay, well, I have RIP and OSPF configured on me right now, but I'm going to use OSPF because it has a lower administrative distance. Now let's try and do that. Let's try and set up EIGRP instead of OSPF. Okay, oops. Okay, now when we configured RIP, we just issued the command router RIP. So since we're gonna do EIGRP, then we're gonna put router EIG EIGRP. Now with EIGRP, after putting the router EIGRP, you have to specify what we call an autonomous system number. Now this autonomous system number is very important. You have to remember what number you will be using, because if you use a different number on all three routers, they will not be able to communicate with each other. Okay, so if you want a router to communicate with the other router, you have to choose a similar number, a similar autonomous system number. So let's say let's put 1 right here, router EIGRP1. Okay, now let's put network again, 150.10.0. Okay, by the way, when you configure router EIGRP, there are some Cisco books that say that no auto summary has already been configured by default on the routers, but there are some instances whenever I read blogs or study groups, they're saying that there are still some routers that no auto summary is not configured. So just for best practices, it won't hurt you if you always have to do no auto summary when configuring EIGRP. Okay, so that's it, and then hit end. Okay, let's do it with router 2. EIGRP. Now remember again, you have to have the same autonomous system number, which is 1. Then put 1. That'll work. And then no auto summary. Just hit enter that one. And it's the router 1. Oops. Okay, so remember earlier when we check our routing table, we only have entries with letter C and letter R. That means C is directly connected and R is RIP routing protocol. Now if we're gonna try and check the routing table, show IP route, now R is gone. Okay, now this D right here means EIGRP. Now you might be wondering, R is RIP, why didn't they use E for EIGRP? Why D? If you're gonna look up here in the table, E has already been used before, right there, E for the EGP routing protocol. So Cisco couldn't use it anymore, so they said like, well, why don't we just use the closest letter that's not been used yet, so let's use D for EIGRP. That's why D stands for EIGRP. Okay, now if you look at here again, EIGRP has administrative distance of 90, that's why it's using it. But you might be wondering, okay, so what happened to the RIP routing protocol that we just configured? Well, the RIP routing protocol is still stored in the routers. To make sure that it's really there, just to show you, you can type in show IP protocols. Now in show IP protocols, it will show you what are the configured routing protocols. Now in the routing table, it says there that we're using EIGRP and 1 is the autonomous system number, and it says here that routing protocol RIP is still configured, but it's not in the routing table because the only entry in the routing table are the ones that the router that's currently using to route packets. Okay, now that we verified that EIGRP is running, well, just to show you, okay, administrative OSPF has an administrative distance of 110. Even when we configure OSPF to these routers, since it already has EIGRP configured, it will not override it. Remember earlier when we configured RIP and then set up EIGRP, EIGRP took precedence over over RIP because it has a lower administrative distance. But just for kicks, let's try and set up OSPF anyway. Okay. Okay, so this time router OSPF because we're doing router OSPF. Now with router OSPF, you have to put another number here, but this is not the same as the EIGRP autonomous system number. This is the process ID, and you can put any number. They don't need to match. Unlike EIGRP, they have to match. Okay, so let's just put like 100 right here. And then network 150, that 10 doesn't do. Now, when setting up router OSPF, you have to set up the wildcard mask. Wildcard mask, this is the reverse of the subnet mask. Okay, with wildcard mask, when you put 0, okay, let's just finish this. Okay, now this means when you have 0 on this octet, that means it has to match with the first octet right here. Okay, so that means it will only entertain networks that matches 150, and that it only entertain network that matches 10, exactly matches 10. Now when you see 255, it doesn't matter what are the numbers in the third and fourth octet. Okay, it doesn't matter. And another thing with when configuring OSPF, okay, you have to specify the area number. Okay, now the area number must be the same in all routers in order for them to communicate. Okay, in this one, let's use area 0. We're going to be using area 0. So that's done. Let's put end on that one. Now let's do router 1. Okay, router OSPF. Now just like what I told you, with OSPF, it doesn't matter with this router process ID right here. It doesn't need to match. I can show you that I can put 200. Okay. But it has to match with the area number, area 0 right there. And router OSPF network. Okay, now let's try and check the routing table now that we've added another dynamic routing protocol. So show IP route. Now if you notice, it didn't change. It's still using EIGRP because EIGRP again has a lower administrative distance compared to OSPF. Okay, but just to show you that the router accepted the OSPF configuration that we did. Okay, so so we have EIGRP, we have RIP right there, and then we have OSPF right here. Okay, now if we wanted these routers to use OSPF as the dynamic routing protocol and not EIGRP, what we have to do is that we have to remove EIGRP configuration in all routers. Okay, to do that, okay, go to global configuration command. Remember when we set up EIGRP dynamic routing protocol, we type in router EIGRP and then the autonomous system number. What we have to do here in order to delete that one is just add the word no before it. So no router EIGRP 1. Okay, now let's try and do that to all the routers. No router EIGRP 1, and where's no router EIGRP, oops, no router EIGRP, come on. Okay, now let's try and check our routing table now that we've deleted EIGRP. So remember, we've configured EIGRP, OSPF, and RIP, and now we've deleted EIGRP. So now these routers should default and use OSPF but not RIP. Okay. Alright, now it says here, it confirms what I just told you. Now these routers are using OSPF as their dynamic routing protocol. Alright, well, oh, okay, just to verify that it really works, router 0 right there. Let's try and ping these two addresses right here. Ping 150.10.6.1. Okay, that's good. And another one right here. Ping 150.10.4.1. Alright, and all good. That means our dynamic routing protocol has been set up properly. Alright, well, thank you so much for watching. I tried my best, and see you guys in my next tutorial. Bye!